Why are design principles so significant in programming? Well, if you've ever found yourself grappling with a code base that feels more like a labyrinth than a well-organized structure, you've experienced the fallout of disregarding these principles. Today we delve into the world of solid principles, a beacon of clarity in the fog of complex code. Imagine you're building a logging framework. It's easy to lump all the tasks, handling, formatting, and storing logs into one class. But then, you'd be violating the Single Responsibility Principle, or SRP for short. SRP insists that a class should have one, and only one, reason to change. In our logging framework, let's have one class for handling logs, another for formatting, and yet another for storing. Each class focuses on a single aspect of logging, making the system more maintainable and easier to extend. Now think about the web browser you're using. Ever wondered how it seamlessly integrates new features without disrupting the existing ones? That's the open-closed principle, or OCP, at work. It states that software entities should be open for extension, but closed for modification. Like a well-designed plugin system, the core functionality remains untouched while new features are added, giving us the best of both worlds, stability and innovation. Next on our list is the Liskov Substitution Principle, or LSP. Picture a vehicle simulation program. Whether it's a car, a bicycle, or a plane, they can all be driven interchangeably. That's because they all inherit from a common vehicle interface. The LSP ensures that each subclass can substitute for the parent class without affecting the program's correctness. Now let's shift gears to the Interface Segregation Principle, or ISP. Imagine a large-scale enterprise application with multiple modules, each having its own set of requirements. The ISP advises against a one-size-fits-all interface. Instead, it recommends smaller, more specific interfaces. For instance, a printing service might offer separate interfaces for color printing, black and white printing, and scanning, allowing modules to implement only the interfaces they need. Finally, we arrive at the Dependency Inversion Principle, or DIP. In a messaging application, high-level modules managing message processing shouldn't depend directly on low-level modules handling network communication details. The DIP proposes that both should depend on abstractions like interfaces. This allows for easier swapping of implementations. So if you want to switch from TCP to UDP, you can do so without modifying the high-level modules. In essence, the solid principles are about managing dependencies, promoting flexibility, and setting the stage for easy maintenance. They guide us through the intricate maze of software design, illuminating the path to cleaner, more efficient code. So the next time you're knee-deep in code, remember these principles. They could be the difference between a well-structured masterpiece and a tangled mess.